Hi, my name's Abe and I'm going to be showing you how to differentiate x to the power of n for any n in this video. Now for those of you who know how to do this, it's not particularly difficult. But where most people fall over is actually recognizing what does x to the power of n look like. You see, x to the power of n comes in many forms, and this is a simple thing to do, but you got to recognize what x to the power of n could possibly look like. So let's start. Obviously, you know what? X to the power of n could look like that. So for instance, x squared, x cubed, x to the power of 40, etc. X to the power of n also looks like this. It can look like this. It can look like that. It could also look like that. Could look like this. Could look like that. And it could even look like that. They're all x to the power of n, right? So very quickly, just to go through what they are. Root x, you know, is just x to the power of half. The cube root of x is x to the power of 1/3. X to the p on q, well, you can call that x to some power, right? So that's just, let's say, you know, x to the p on q. 1 on x to the power of n is just x to the power of negative n. 1 on root x is just x to the power of negative half. 1 on the cube root of x is x to the power of negative 1/3. And 1 on x to a fraction is just x to the negative of that fraction. Pretty simple, right? Okay, so all of these can be converted. So all of these can be made to look like x to the n. Okay, now that we've got this straight, I'm going to tell you that the way you differentiate these is all the same. Really simple. And I'm going to write a simple formula here. It goes like this. This d dx just means derivative of x to the power of n is equal to n times x to the power of n minus 1. That's for n not equal 0. Or just equals 0 if n equals 0. Simple, right? Very simple. Very simple. So what you would have been taught in school is take the power, bring the power out the front, and minus 1 from the power. So the old power comes out the front, and the new power is the old power minus 1. Simple, right? Or if you have to take a derivative of a constant, so i.e. x to the 0, because you know that x to the power of 0 is just 1, right? We all know that. So derivative of 1 is 0. Derivative of a straight line is 0. Pretty simple, isn't it? Okay, now that we've got that out of the way, very quickly I'm going to do some fast examples. The first one, not too hard. 4x to the power of 4 minus x. Right? So find the derivative of that. And that's simple, right? So we have, remember the 4, if it's multiplying, you just leave it. 4 times. Now what do we do with the power? You bring the power out the front. So 4x, and then you want to take 1 away from the power. 4 minus 1 is going to be 3. Now, x is actually, let's just make a mark, that's actually x to the 1, isn't it? So, if you were to take 1 away from its power, you'll get 0. So we bring down the power, which is 1, and then we can multiply by x to the power of 1 minus 1. Yeah? So, simplifying that, you simply get 16, 4 times 4, x cubed minus 1. Done. Very simple, isn't it? Okay, second example. Find the derivative of the cube root of x plus 2 times x to the power of 4 on 5. Okay, a little bit harder. Alright, I'm going to do exactly the same thing. Now, the cube root of x, remember we've said before, is just x to the power of 1/3, right? So, what is the derivative of x to the power of 1/3? You do exactly the same thing. You take the power out the front, so you say 1/3 x, and then the new power is the old power minus 1, right? We'll simplify that later. Plus, okay, the second part, 2 times, now that's just x to the n, so again, we're doing the same rule again. You'll find that on every term we're doing exactly the same thing. X to the power of 4 on 5 minus 1. Let's simplify. You'll see that 1/3 minus 1 is negative 2/3. So you're going to be left with 1/3 x to the power of negative 2/3 plus 2 times x to the power of 4 on 5 minus 1. 4/5 minus 5/5 is 1/5. So 1/3 x to the power of negative 2/3 plus 2 times x to the power of 1/5. What did I forget? I forgot to bring the power down, didn't I? You gotta put 4 on 5 there. Sorry about that. And the other thing I want to add is that you shouldn't leave negative powers in your answer. So this is what you should do. Instead of having x to negative 2/3, you know you could just make that 1/3 x to the power of 2/3 on the bottom, right? So you can take away the negative by putting the term onto the denominator. And the second part, well, 4 on 5 times 2 is 8 on 5. So 8 on 5 x to the power of 1/5. And there we go. That would be your final answer. Cool. Last example. Find the derivative of 1 on 2 root x minus 40. Okay, so let's do this. First thing to realize, 1 on 2 root x is half times 1 on root x. What is 1 on root x? X to the power of negative half, right? And 40, imagine 40 just as 40 times x to the 0, because x to the 0 is 1, isn't it? Okay, so now that we know that, we can do half times, now x to the power of negative half, you got to bring down the power, and then the power minus 1, right? Okay, now this 40 times x equals 0, or x to the power of 0. Remember, in this original formula here, in my original formula here, x to the power of 0, if n were to equal 0, what is the derivative of x to the n? The derivative is 0. So, you're simply going to get 40 times 0, which is just 0. So the whole thing comes out as negative 1/4 x to the negative 3 on 2. And simplifying like we did before, what you want is for the positive power to stay on the bottom, or so the power to end up positive, so bring the x onto the bottom. So you get negative 1 over 4 x to the power of 3 on 2. And that's it. So we've covered pretty much every case for x to the power of n, and hopefully you're now much better at recognizing what they're supposed to look like and you won't get tricked. So yeah, hope you've enjoyed yourself. I'll see you next time.